Nice big green check. Yeah, boy, 6.2 was really in depth, but it's where the power of computers come from. 6.3 can almost be an afterthought. It's a cool little optional way of accessing arrays, the enhanced for loop. Everything in here is good. This is going to be really fast. Here we are. The key thing to know about this is really the learning about the use of advanced for loops is just rote. It's a different vocabulary, a nomenclature, sentence structure, if you will, for the for loop. But there's some limitations on it. The good thing is that students don't have to do indexing. The bad thing is you can't use indexes if you need them. You can't modify the array at all, and you can't loop over just part of the array. And for these reasons, I'm just telling you, your students will not want to use them. And generally, that's fine. They will probably need to be able to read multiple choice questions that are using them on the exam. That's okay. They don't have to remember the format for that, as long as they know enough to be like, oh yeah, that's that thing that just loops over all of them. That's fine. They don't need to write code with the enhanced for loop ever, necessarily on the exam, and maybe for a lot of life, who knows. All right, this will be brief and fast. Enhanced for loops, if you've done App Inventor, you've seen them. If you've done Snap, you've seen them. They're very useful, right? Just give me each of the items in the list one at a time and let me do something to them. Well, you can do something to them in that enhanced stuff in Java or in Snap, but not in Java. So the original example gives you two different examples. We've got an array of ints, high scores, and an array of string names. Shows you that here's the nomenclature. For int value, colon, and value can be any word you want. That's a variable name, colon, the name of the array, and then open bracket, close bracket, and whatever you need in there. So printing, whatever. Second example is for strings. It's exactly the same. There's really no difference at all. It's just saying you can do that. But again, for parentheses, the type, the variable name that you want to use for the item, colon, and the array name. There's very quickly after that an example that basically just shows exactly how it goes. So have students run this. If you really need to make up time, don't, because it's just going to run. It just shows those same two loops. The next one is a good one. It says rewrite the for loop that's for int I equals 0, I less than values.length to make it a for each. Fairly simple, this, that, and the other, and they're just going to replace it. They're going to have to come up with a new variable name like item or value or something like that, and then replace the use of value sub I inside the loop with that item or value. For each loop limitations. Told you there were limitations. This is a demonstration code that runs, but it shows you that it doesn't do what you think it does, which is a nasty part of the for each loop. So it won't say there's an error with you, changing something to it, because you can. There's some legitimate reasons for that we don't care too much about, but it won't have any impact after the loop is over. So here's a for loop, an enhanced for loop. It grabs each item out of values into the val. It updates that by 1. And actually prints it out right there. And so you see down at the bottom, I've got the output. And you see that the original one was 6, 2, 1, 7, 12, 5. Now it's 7, 3, 2, 8, 13, 6. Added 1 to each. But if we then loop, using the same, for each loop, you could use a for loop as well, and print out the values in values, after that, you'll see they didn't change. And see, that is why kids don't like it, because that just doesn't make sense to them. It's fine. So again, the key thing, the enhanced for each loops, you can't use them if you need the index for some reason. Like I need to do index plus 1. You can't use them if you need to change the values. And you can't use them if you want to loop through only part of an array or anything other than regular order. So lots of limitations. That said, a lot of times we just want to go whoosh over all of them, and that can be good. Two questions that really just follow up, making sure students understood those rules. And we're on to for each loop algorithms. And the example they're going to give here is a gather. A gather is really good. You can do a count. You can do checks. You can even do most wanted. You can do almost everything with for each loops. I'm not saying all of them, but again, as long as they meet our requirements. So again, working in this sort of odd class situation where I've got a class that has a single instance variable that's an array of ints, in this case called values, and a constructor that takes in an array, actually a reference to the array, and does it there. We're basically, look at the main part on the bottom in line 24. We're going to be writing the get average program. In fact, actually it's written for us. The key thing here is that get average. Why can we use a for each loop? That's what we want to have. We don't need an index. It's not modifying the array, and it doesn't loop over just part of the array. Again, this is a straight gather, loop over every single one. In order is fine in this case. Adding it to a total, at the end we return the average. And again, that looks like we got an integer division error. Total is a double. I still don't like that, but anyway, whatever. Then there's a couple of, or at least one, no, there's two, mixed up code problems. And these I missed this actually in 6.1 and 6.2, or at least 6.2. I think that's the first place I saw one. They've added a new feature. I don't know if it was even particularly mentioned, or I skimmed over it, if you didn't. I did, this is the correct solution for all of this, but look at all those yellow arrows. They're checking indenting. And if you see, you can just barely see it, and if you go on the one you can see better, see there's little yellow lines on the right, so we could choose to drop it in a shorter or bigger thing, and it actually doesn't give you a hint because the original tiles are all the same length. They auto shrink them based on where you indent them. So it gives you this thing, these blocks are not corrected indented correctly, blah, blah, blah. Reminder, you don't have to indent correctly for Java to run your code correctly. But the reason it's valuable for students to practice this is because when they're writing code on the free response question of an exam, if they forget the open bracket and close bracket, but their indenting shows they're trying to say this is part of this for loop, they will give them their points for that. And this is the correct solution for it. So now you see it all it's nice and green, and you see even more. See those lines, those light green lines that go down? That's sort of showing the indenting for each one. And the other reason I think indenting is really nice, because we do know that students really focus on format. And one of the reasons I like to always use if, whatever, and an open bracket and a closed bracket on the same line, and always, no matter how many how many instructions are in there, is kids really, really focus on format, and they lean on that as a reasonable crutch to reduce the cognitive load in looking at some code that's randomly formatted to find patterns and make sure that things are in the right place. So this is a good thing. There's another multiple choice question. I just want to bring it up for you because it's not super tricky, but most people would not write code this way. I would say, and I think it's an odd use of an assigned to Boolean variable. What this code does is it's because the for each enhanced loop loops over all elements in the array in order, it's saying the last time, because every time through the loop, it's saying if target equals val, set temp to true. And then it would be false, and then true, and then false. And that just makes me realize I might have my solution incorrectly. No, actually I think I got it. I wrote the regular one. This isn't the same code. All right, get ready for the mysterious plop. Okay, I've now replaced my code that was wrong with the code that is correct. The key thing here is that every time through the loop, temp gets updated. So it's either that it gets updated to true or updated to false based on what was and essentially this is silly code because it's basically saying, tell me true or false whether the very last element in an array is the same thing as temp. So it's really nonsensical kind of trick code that only a Java instructor would give. Never write this in the real world. There we are. Finally, the programming challenge. It's the same thing as last time. It's the spell checker. Just copy your code over, replace your for loops with enhanced for each loops, except, oh wait, maybe that's why we had that warm up for writing print 10. You can't print the first 10 elements of an array using a for each loop. You can't. It does them all. So that one's just going to stay a for loop. And you can change the second one to a for each loop. And sorry for the formatting not quite matching. These updates are going into the textbook, but they're not quite there yet. And here is the solution for the one that you can change, the spell check. Takes a string, W, the string you're looking for, found as false, for string word colon dictionary. Dictionary is our array of strings that is an instance variable. Word is going to be our item, if you will, the thing that holds the value each element in the array. And we just check if W equals word.